दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Dear students, we will be discussing a very important topic, oxidation reduction. The things which are there in this topic are oxidation, reduction, oxidation number, oxidizing agent, reducing agent, redox reactions, balancing redox reactions by ion electrode method. It is one of the very important topic which involves the knowledge of families, and when we will be studying the families and studying different chemical stoichiometric reactions, we will be having application of this. So now coming to oxidation and reduction. So first let's come, what is oxidation? So when you come to oxidation, the oxidation is a chemical process, which involves any one of the following reactions. So there are various type of chemical reactions which are called as oxidation. So oxidation is a chemical process which involves any one of the chemical reactions. What is that? The first is addition of oxygen. Addition of oxygen. If in any reaction oxidation is added, we call it is oxidized. For example, you have carbon and we add oxygen to that. This forms carbon dioxide. So we will say the carbon is oxidized to carbon dioxide. When carbon becomes carbon dioxide, what happens? Suppose question comes. We say the oxygen is added, hence the carbon is oxidized. Or we have iron, and we are adding oxygen to that, and this forms FeO. So the formation of ferrous oxide from iron is the oxygen is added to iron, so we say that it is oxidation. Second, removal of hydrogen. From in any reaction, if the hydrogen is removed from a compound or a substance, the substance is said to be oxidized. For example, we have ammonia. We have ammonia gas. Nitrogen combines the hydrogen to form ammonia. From ammonia, if this ammonia forms nitrogen, we say ammonia is oxidized to nitrogen, or nitrogen in ammonia is oxidized to nitrogen gas. That anything we can say that. Now next comes in addition of electronegative element. In any reaction, if you are increasing any one of the electronegative element to that, we call that is oxidation. For example, we have stannous chloride. The stannous chloride is converted to stannic chloride. So 2 atoms of oxygen and a chlorine are present in tin stannous chloride. Now 4 atoms of chlorine are there. So here 2 chlorine atoms are added. Hence we say that it is stannous chloride is oxidized to stannic chloride. For example, we have ferrous chloride and it is oxidized, said to be oxidized to ferric chloride. Then increase of, next one, increase of positive valency state. Increase of positive valency state. In any reaction, if the positive valency state of a reagent, a substance is done, then we say it is oxidation. For example, we have copper cuprous oxide, Cu2O. This forms cupric oxide. So somebody will say, here is one oxygen, here is one oxygen. No, what was there here? Cu2O. Here the valency, positive valency state of copper was 1, and here the valency is become cupric 2. Or we have mercurous 1 and this becomes mercuric 2. So here the positive valency state is oxidized, is increased. Positive valency state is increased. So we say that this is also oxidation. So then decrease of negative valency state. Negative valency state. Decrease of negative valency state. For example, we have iodide, I minus, and this becomes iodine. This becomes iodine. Here the negative charge was -1, now this becomes 0. So negative valency state becomes 0. So there is a decrease of negative valency state. Or we have oxide, O-2, and this becomes oxygen. This becomes oxygen. So we say this is again oxidation. Now the very important, all these things can be put into one that is called any loss of electron. Loss of electron. Any chemical process which involves loss of electron. Loss of electron is oxidation. Is oxidation. If in any reaction an atom is losing electron or an ion is losing electron, then it is called oxidation. So we have, suppose you have ferrous +2. This becomes ferric +3. So there is a loss of 1 electron. 1 electron is lost. Or we have stannous +2. This becomes stannic +4 and loss of 2 electron. Or oxide O-2. This forms oxygen +2 electrons. Or we have hydrogen atom. When this hydrogen atom becomes H+ ion, the process is, all these are oxidation, and all these from Fe plus 3, they are the oxidized state. We call them as oxidized state. This is called as the oxidized state of H plus is the oxidized state of hydrogen. Oxygen is oxidized state of oxide. Stannic is oxidized state of stannous. Ferric is oxidized state of ferrous. So any process, any chemical process which involves addition of oxygen, removal of hydrogen, increase of electronegative element, increase of positive valence state, decrease of negative valence state, and or loss of electron is called oxidation. So in one thing you take, you see when electron is lost, positive valence state is increasing. So increase of positive valence state is oxidation. So the loss of electron conforms to that. Decrease of negative valency, you see minus 2. Here is minus 2 and this becomes 0. So decrease of negative valence state is also loss of electron. So loss of electron involves increase of positive valence state, decrease of negative valence state. So one thing, if you say loss of electron is oxidation, then two processes we are explaining that. And addition of oxygen is again, it will increase the positive valence state, and that will involve the loss of electron. In all this process, we can say that the substance is stays to be oxidized. So this substance and this is they are the oxidized state. All the substances are oxidized state. Now we'll come to the what is called reduction. So this reduction is a reverse of oxidation is called reduction. So if you come to reduction, any chemical process which involves any one of the following reactions is called reduction. So what are they? Just the reverse of oxidation is reduction. But what we have done in the first, we say that addition of oxygen. So we'll say here removal of oxygen from any substance. If oxygen is removed, we say it is reduced. For example, you have cupric oxide. Cupric oxide is black and this becomes copper. If you have cupric oxide, the color of cupric oxide is black. The moment it becomes cherry red, the color of copper is cherry red. The moment oxygen is removed, the copper oxide loses its black color and becomes copper. Oxygen is removed. Or we have zinc oxide and this becomes zinc. Then it is, we say that it is reduced because the oxygen is gone. So any process which involves loss of removal of oxygen is called reduction. The next is that there you have done removal of hydrogen. Here you will say addition of hydrogen. So it is whatever we have done in oxidation, here the reverse is called reduction. So removal of addition of carbon we have, and we have add 2 molecules of hydrogen to carbon or 4 atoms of hydrogen. So we get methane. This we call as the methane. So carbon is reduced to methane. Carbon is reduced to methane. Or we have the nitrogen and we add hydrogen to that and this becomes ammonia. So the formation of ammonia from nitrogen is this process is called reduction. We have the nitrogen added 3 atoms of hydrogen are added to 1 atom of nitrogen, it forms ammonia. The reaction is called reduction. If you balance it, you will write N2, 3S2, 2NH3. We will write in a balanced form. If you write, you can write like this. So here you are adding hydrogen to nitrogen to get ammonia. The process is reduction. Or you remove oxygen. Suppose that a compound is there. You add hydrogen and remove oxygen. So that reaction is also called reduction. So then comes decrease of removal of electronegative element. Removal of element. Any reaction. So we have the removal of electronegative element from any substance. If we are going to remove electronegative element, for example, we have stannic chloride, SnCl4. We remove 2 chlorine atoms and this becomes stannous chloride. So tin is reduced from stannic chloride to stannous chloride. Or we have ferric chloride to ferrous chloride. So this is also, we say, is a reduction. So these are the examples we can take. Then comes decrease of positive valency state. Decrease of positive valency state. Suppose we have stannic plus 4 and this forms stannous plus 2. Stannous plus 2. Or we have mercuric plus 2 and this becomes mercury. So it is a mercuric ion, and when this becomes metallic mercury, the process is reduction. We have sodium plus 1 and this forms sodium. So when we will read say extraction of sodium, electrolytic reduction of fused sodium chloride. Electrolytic reduction of fused sodium chloride. So sodium chloride, in sodium chloride, the valence state of sodium is plus 1 and we will do the electrolysis. During electrolysis, the 1 electron is added to sodium plus and this forms metallic sodium. We call the process as electrolytic reduction of sodium chloride. So if a student knows these languages, these are the languages. These languages, if one understand what is the meaning of the word, then you can easily understand what is going on in a chemical reaction. When you will study the extraction of metals, preparation and properties of chemical substances, we can very easily understand there. Now then comes increase of negative valence state. Increase of negative valence state. Negative valency state. Suppose we have iodine and iodine becomes hydrogen iodide. Iodine becomes hydrogen iodide. Here the valence state of iodine is 0 and in hydrogen iodide this becomes -1. When iodine is converted to iodide, the process is called reduction. Or we have chlorine and this becomes HCl. So this is a reduction. So here the chlorine, the positive, here the in 0 state and this becomes -1. This becomes -1. So in where you will have the increase of negative valence state, so the process is called reduction. Now to explain all this, these are the previous ideas about oxidation reduction, and electron proton came in the year 1900. Then whole chemistry, the screen changed. Everything they wanted to discuss with respect to electron, everything they want to discuss with respect to electron, because the electron is the fundamental particle of atom of an element which is involved directly in chemical reactions. In all chemical reactions, the electron is one of the fundamental particle of atom is directly involved. The formation of compounds, two atoms, when take part in chemical combination to form a molecule, it is the electron is involved. Either the electrons are lost or gained, the electrons are shared, or electrons are donated and shared. So that we have read in the octet rule. 19 and towards after the discovery of rare gas, soon after the discovery of electron, and seeing into the chemical stability of the inert gas atoms, then the rule of octet came, and which led to the electronic theory of valency. Then all these reactions which were known as addition of hydrogen, removal of oxygen, decrease of electronegative element, decrease of positive valence state, increase of negative valence state, all these are one thing is happening, that is called addition of electron. So we'll say now here any process here addition of electron is reduction. If in any process, so those reactions in which electron is added are called reduction. The atom of the element or the substance is said to be reduced. For example, we have hydrogen atom. Hydrogen atom has one electron. It has atomic number 1, it has one electron. So when we add electron, this forms H-. It is called hydride. So we say hydride. We say hydrogen is reduced to hydride. Or we have chlorine, and we add electron. This forms a chloride, Cl-. So the chloride is more stable than chlorine. Chlorine has 7 electrons. It is placed in the 7th group of the periodic table. Has atomic number 17, 2, 8, 7. Needs 1 electron. The moment 1 electron is added, it forms chloride. So here the electron configuration of 2, 8, 7, and this becomes 2, 8, 8. Chloride is more stable than chlorine. So chlorine has a strong tendency to become chloride. 2, 8, 8. So or we have oxygen. When we add 2 electrons to oxygen, this becomes oxide. Or we have iron, Fe+2, and we add 2 electrons to this, and this becomes iron metal. The process is reduction. Almost all the metals are prepared by electrolytic reduction of their compounds. electrolytic reduction, carbon reduction. We will be reading many processes. If we use we know the meaning of the word reduction is a process. You will be seeing hydrogen is not added. You will be seeing oxygen is not removed, but the process is called reduction. Electrolytic reduction of sodium chloride. So there is not addition of hydrogen. There is no removal of oxygen, but the process is called reduction because there is process is addition of electron. So any process in which the electron is added, the process is called reduction. So now then comes to explain this oxidation, to explain this reduction, whether oxidation is going on in a reaction or a reduction is going on in a reaction. How to know a reaction is going on, and how to know this? So to know that, they have used a number that is called oxidation number. So till this moment I was using a word valence state. I am very careful in using this word. I am not using valency because I know valency is a number, does not have any charge with it. This is there in my mind from fundamental concept. Very often we use the word valency. No, valency is a number, does not have any unit and does not have any charge. It does not have any charge. So that is I am using valence state. When I am using valence state, it is +2 or +3. So that is not valency, that is the valence state. So that valence state word is replaced by the word called oxidation number. And so to use this word oxidation number, now they wanted to explain, it was necessary to explain whether the oxidation is going on or a reduction is going on. In a chemical reaction, whether oxidation is taking place or reduction is taking place. So to explain that, then this oxidation number concept was introduced. So we'll come now, what is oxidation number? Oxidation number. The oxidation number is defined as the charge. When I use the charge, it may be positive or it may be negative or zero. It may be positive or negative or zero. So the oxidation number is defined as the charge, an atom of the element, appears, I am using word appears, to have, assuming that, again this word is important here, assuming that all other valences are ionic in its state of combination. So please read this sentence very carefully. Oxidation number is defined as a charge. What is that charge? An atom of the element appears to have. What do you mean by he appears like him? So he is not him. It appears like a gold. Suppose you have a metal. It's not a gold, but you say appears to be gold. Appears to be gold. So gold is dazzling. It is dazzling. Gold is gold, yellow, it has a yellow color and it has a shining, so you will say that appears like gold. All that glitters are not gold. There is a proverb, all that glitters are not gold, gold glitters. So that which glitters is also not gold. So we have to say appears. Appear is not a truth. Appear is not a fact. Appear is not present. That there may not be charge, but it appears to have a charge. So you will say that the oxidation number is defined as the charge, positive, negative or zero. An atom of the element appears to have, assuming that all the other valencies are ionic. All the other valencies are ionic. What? In its state of combination. I am putting a comma here. And the oxidation number is defined as the charge, positive, negative or zero. An atom of the elements appears to have, I have put a comma here, assuming that all other valencies are ionic. Here also I am putting a comma. In its state of combination means in the state of combination of the atom of the element in a compound, if we assume all the valencies are ionic and calculate the charge on the atom, that will be its oxidation number. Could you understand my idea? What I am saying, going to tell you? The oxidation number is defined as the charge, positive or negative or zero. An atom of the element appears to have in its state of combination, assuming that all the valencies are ionic. Suppose in a compound we have, let's come to a very simple compound, ammonia. So ammonia is a covalent molecule. It is not ionic. Ammonia is not ionic. But we want to calculate the oxidation number of nitrogen. So what we will assume, the hydrogen is combined to nitrogen by ionic linkage. Then what is the charge? So hydrogen is bonded to nitrogen. Hydrogen is +1. So nitrogen must be what? -3 here. So the -3 is the oxidation number of nitrogen. So there is, what is happening? Now to nitrogen you are adding hydrogen. Addition of hydrogen is reduction. So you have a negative charge, that will tell you reduction has taken place. So I will come to that, explain you, but I am giving an example. For example, methane. We have methane. Is carbon, we will calculate the oxidation number of carbon. How will you assume? The carbon is bonded to 4 hydrogens. By what? Ionic linkage. But actually carbon is bonded to 4 hydrogens by covalent linkage. They are not ionic. No, we are assuming they are ionic. They are not exactly ionic. We are assuming ionic, and we will calculate the charge. That charge will be equal to this. Then why this botheration? Somebody may put a question, sir, why this botheration you are taking? Oxidation, reduction is going on. No. By one thing, by calculating the oxidation number, we can say that oxidation has taken place or reduction has taken place. So then what is the significance of oxidation number? It explains. What is this oxidation number? It explains the extent of oxidation or reduction, done to the atom to bring to that state of combination. So you want to say whether nitrogen is oxidized or nitrogen is reduced, hydrogen is oxidized or hydrogen is reduced, calculate the oxidation number. So that number will tell us whether it is oxidized or reduced. For example, we have nitric oxide and we got nitrous oxide. You see here one oxygen, here also one oxygen. So there is no change in oxygen. Neither oxygen is removed nor oxygen is added. But we want, there is an oxidation, reduction, oxidation took place. Reduction reaction has taken place. What we will do? We will calculate the charge of nitrogen and we will calculate the charge here in nitrogen. In nitrous oxide, we will calculate the charge of nitrogen. In nitric oxide, we will calculate the charge of nitrogen. and from that charge is the oxidation number. If oxidation number is increasing, it is oxidation. If oxidation number is decreasing, it is reduction. So by using one number, there is no reduction number. There is no reduction number, only oxidation number, because you have read vectors. If you have the graph paper origin 0, if you go from 0 origin to right, it is x axis, you say x positive, and when you go from 0 origin to left side, it is called x dash, there is negative. If you come to 0, if you go to y upward, then it is positive, and if when you go 0 downward, it is negative. So the direction. So here also you are using from the same knowledge of vector. When you have a one direction, the opposite direction is negative. So we use the same symbol and we can say extent of that. Here also exactly we are doing the same thing. By using one word oxidation number, we can tell then oxidation or reduction has taken place in the chemical reaction. Then what is the oxidation number? Now the oxidation number explains what it does. It explains the extent of oxidation, the extent of oxidation or reduction done to the atom, to bring to that state of combination. So from an element you are coming to a compound, or from one compound you are coming to another compound, whether the atom is oxidized or the element is oxidized or the element is reduced, we can say this by calculating the oxidation number, by determining the oxidation number. The oxidation number explains the extent of oxidation or reduction done to the atom. Why? In atomic state, while atom is used, in atomic state, the charge on the atom is 0. The charge on the atom is 0. Atom is electrically neutral. Charge on the atom is 0. So from 0, if you have come to positive, it is oxidation. From 0, if you come to negative, it is reduction. Because why? Now increase of positive valency is oxidation, decrease of positive valency is reduction, or increase of negative valency is reduction we have used. So to explain all these things, increase of positive valency, increase of negative valency, decrease of positive valency, increase of negative valency, all these things not necessary at all. Addition of oxygen, removal of hydrogen, all this confusion is not necessary at all. Calculate the oxidation number, and if there is an increase of oxidation, it is called oxidation, and decrease of oxidation number, then it is reduction. Then extent of oxidation, whether oxidation has taken place or reduction has taken place. So increase of oxidation number, increase of oxidation number, ON I am writing children, oxidation number is oxidation. If oxidation number is increased, it is oxidation, and decrease of oxidation number is reduction. So that is the way it explains the oxidation state. Whether it's, suppose you have ferrous and you have ferric, it's a ferric chloride. So here the charge on ferric is +3. Oxidation number of iron is here +3. And this becomes ferrous chloride. So here charge is +2. Oxidation number is +2. Then again it becomes iron, Fe. Here the charge is 0. So ferric chloride to ferrous chloride is reduction. Ferric chloride to ferrous iron is also reduction, because there is a decrease of oxidation number, +3 to +2 to 0. You have stannous chloride. We have stannous chloride and the stannous chloride becomes a stannic chloride. So here we have the oxidation number of stannous is +2 and it is +4. So there is a increase of oxidation number. So this reaction is oxidation. Stannous is oxidized to stannic. We can say by using the concept of oxidation number we can use. So oxidation number, this is a decrease of oxidation number is reduction, increase of oxidation number is oxidation. So if how much oxidation, how much the charge is decreasing, that will tell us the amount of oxidation or reduction done to the atom to bring to that state of combination. So then how to calculate the oxidation number? So we'll use some standard values are there. Very unknown is always measured by a known. And unknown is always known by a known thing. To have a cloth, we take a 1 meter of scale, then we go on how many scales are there in the cloth, then you say 10, so 10 meter cloth. You don't know the length of the cloth, but 1 meter scale you brought, that is 1 meter, so 10 times, so 10 meter. So we'll have some standard values. They took some standard values, and from the standard values they have calculated that we will calculate the oxidation number. So determination of oxidation number. Determination of oxidation number. So first is the oxidation number. ON I am writing, children. ON means oxidation number. So the oxidation number of any element in atomic or molecular state is zero. For example, you have hydrogen, oxidation number is 0. Hydrogen atom, hydrogen molecule, the oxidation number is 0. You have nitrogen atom, oxidation number is 0. Nitrogen molecule, the oxidation number is 0. If you come to methane, the molecule, the oxidation number is 0. So methane molecule, the oxidation number is 0. So in any atom, in its molecular state and atomic state, oxidation number is 0. Then second is oxidation number. Oxidation number of hydrogen is always +1. Is always +1 except the case of ionic hydrides. Ionic hydrides where it is -1. Where it is -1. What is this? Now for oxidation number of hydrogen is always +1. Why? The valence is 1. But hydrogen is a peculiar element in the periodic table. You will find in the periodic table, hydrogen is there in group 1A, also there in group 7A. It's a dual character of hydrogen because it has one electron. It can lose the electron, form proton H plus stable. And it can take an electron also to become H minus and stable. Helium structure. When it takes an electron, it becomes a helium structure, stable. When it loses electron, it forms proton, stable. So, but it is very difficult to add an electron, but easy to lose an electron. So always that is +1 except the case of ionic hydrides. If you come to ammonia, here the oxidation number of hydrogen is +1. Here hydrogen is considered as +1. If you come to methane, it is +1. If you come to water, it is +1. Here all it is +1. But if you come to sodium hydride, NaH, here hydrogen is minus. If you come to calcium hydride, it is minus. Ionic hydride. Why? I have told you the sodium is more positive than hydrogen. So sodium is positive, so hydrogen is negative. With respect to sodium, hydrogen is negative. Calcium is more positive than hydrogen. So with respect to calcium, hydrogen is negative. So it is a hydride. Sodium hydride, calcium hydride. So here it is placed, here it is +1, but here is -1. Here +1, -1. So but here hydrogen water is +1. So oxidation number of hydrogen is always +1 except the case of ionic hydrides. Similarly, another standard value is oxidation number of oxygen is -2, is always -2 except in peroxide O2 -2. Peroxide is O2 -2 where it is -1. Where it is -1. So it is always -2. If you take carbon dioxide, here oxygen is -2. So you can calculate carbon is 4. If I have water, here oxygen is -2. Charge of oxygen is -2. If you come to say sodium peroxide, if you come to sodium Na2O2, so here it is O2 is -2. O2 is -2, so it is -1. Hydrogen peroxide, H2O2, so here O2 -2, it is peroxide. It is a peroxide. Na2O2, sodium peroxide, H2O2, hydrogen peroxide. Oxygen has a +2 valence oxidation number. The oxidation number of oxygen is +2 in F2O. Difluorooxygen, fluorine oxide you can call it. So why? Now fluorine is more negative than oxygen. So here it is written F2O, but here fluorine is -1. So 2 fluorine we have. So we have 2 fluorine. So we have -1 into 2. So here oxygen is +2. So 2 fluorine -2, oxygen +2. In one molecule oxidation, oxygen has the oxidation number +2 F2O. Or sometimes you can write also, if you go by, first you write the basic radical, then you write the acid radical. If you go by formula, then you write OF2. You can write also OF2. So oxygen is here +2 and fluorine is -1 into 2 -2. So the total molecule is 0. So in molecular state, all molecules have oxidation number 0. In atomic state, all elements have the atomic number 0. The oxidation number of hydrogen is always +1 except the case of ionic hydrides. Oxidation number of oxygen is always -2 except the case of peroxides where it is -1, and it is in F2O or OF2 the oxidation number of oxygen is +2. So in next class I will talk to you the other rules, other standard values. We will take the standard values and use those standard values in calculating the oxidation number of atom of an element in its state of combination. That will explain us what extent of oxidation or reduction done to the atom to bring to that state of this. So in oxidation number, I told you children that appears to have, it is not having a positive charge, exactly it's not having a negative charge. We are assuming that all the valences are ionic and we are calculating the charge on that, and that charge will give us this oxidation number. So next class we will discuss all other standard rules to calculate the oxidation number of atom of any element in any molecule or in any ion.